So here we go. This will be fast. There are a couple of things that aren't on here that I kind of wish were, but actually this is good. This is good. We can cover. We'll spend a little bit of time on this particular screen. This is kind of where the I feel like this is really important. Now, there's no objective about this on the AP exam. There never has been. There probably never will be. But I think they're kind of missing the opportunity to ask some relevant questions here because you guys deal with batteries all the time, right? And so they give examples in the book of some different types of batteries that you might deal with. This one right here, the one at the top, this is your lead acid battery, okay? And a lead acid battery, basically the way that that's set up is with lead and lead oxide as the two electrodes, okay? Now the advantage to having two solids as your electrodes is it can be reversed, right? So this thing can be recharged, okay? And so that's one type of battery that's very important. You basically connect, I think it's 6 of these in series, and you end up with 12 volts, because I think you get about 2 volts from each of them, each of the cells, if I remember right. So you connect 6 of them in series. Car batteries are nasty, though. I mean, they're lead acid batteries. So they're filled with lead and sulfuric acid. So this is not the kind of thing you want to get on yourself, right? That's why you have to be careful with these batteries. That's why you have to be very careful with the disposal of this type of battery. But this is what's going to be used in your car if you have just a normal, everyday, run-of-the-mill car. And you only need 12 volts because you just need enough to get the car started, right? And then does anyone know what recharges the battery while the car is actually running? Well, but what specific part of the engine? Okay, thanks. What's that? Well, I mean, it essentially is a generator. Right. You might work on your pronunciation, but it is the alternator, right? That's the part. So actually, I had a car in college and a little bit after college that had alternator issues for a while, and I knew it was the alternator because the car would start, but then shortly after starting, it would die, right? And the alternator is supposed to keep the car going. So anyway. But the alternator will recharge the battery while you're driving so that the next time you need that 12 volts to start the car, it's there. All right? So that's a lead acid battery. That's one major type of battery that you would experience in your life. And you should read a little bit more about these in the book because since I think this is important because it's actually relevant, I keep saying actually relevant. There's a lot of AP chemistry that's been relevant, but this is very, very relevant. Okay, but because I think it's relevant, you're probably going to see some sort of question on your next test that has to do with batteries. So you need to know this stuff. It's not going to be on the AP exam, but it will be on my test. All right. Another type of battery is your standard, not nickel cadmium. Why am I blanking all of a sudden on what this is called? Alkaline? Thank you, alkaline. That was not coming to me. And the reason it's called alkaline is because you have potassium hydroxide in there. So most of the electrolysis we have done, not electrolysis, most of the galvanic cells or voltaic cells we've done in here have been in the presence of acid, right, H+, but this is going to be in the presence of concentrated base, which is, again, why you have to be careful with the disposal of even these alkaline batteries. Alkaline is just another name for basic. All right. Did we know that? Had I taught you that? Okay. So that's another type that you can have. And, again, the book kind of talks about how those work. Oh, here it is right here. Okay. So this is an elaboration on the... I just blanked on the word again. Why does that alkaline? Why does that keep happening? It's so weird. So this is a kind of a close-up look at what's going on there. So in your anode, you've got zinc in the presence of potassium hydroxide. Then your cathode is manganese. I guess you'd call that manganese oxide. I don't know why I want to call that manganese dioxide, because that's not the way you would name that. That's a metal and non-metal. And then you've got some graphite in there as well. Okay, so that's your typical setup for, the normal. And the 1.5 volts is your AAA battery. Okay, so then, you want a higher voltage than that. You've got to get bigger battery. You've got to have these connected in series so that you get a higher voltage. But this is the typical voltage you can get out of that reaction. So that's another type. There's a couple of types they don't have up here. They have the, I don't think they have up here. Let me see. Yeah, they don't. The NiCad battery, nickel cadmium, and that one's used a lot with power tools and stuff like that, or it used to be. I actually worked at a company called Granger before I got back into teaching, and they sold these rechargeable NiCad batteries a lot, and you could actually, they were very heavy, but then they had just started transferring over to the lithium-ion batteries, so you could hold the two of them in your hands, and I mean, there's a huge difference between the weight of the lithium battery and the weight of the nickel-cadmium battery. And the lithium, the nickel-cadmium, you've got some disposal issues as well, because cadmium is a heavy metal. So, just a lot of issues with how to dispose of batteries, but obviously we need them to live the kind of lives that we live. So nickel-cadmium, what else do you have? I just said the lithium-ion batteries. That's a big one now. And the lithium-ion batteries are a lot lighter, a lot more efficient at and you can get a higher voltage out of them. So that's where really the direction of the bigger batteries is going. What else? Well, okay, so your lithium-ion batteries, those are going to be also, that's going to be what's in your phone, what's in your computer, your laptop. So, I mean, those are incredibly important to us now. So those are some of the batteries that, and all of these batteries are basically just voltaic cells like we've been setting up in class, like we've been learning about in class. It's just, which chemicals are you going to use in order to make the reaction occur, okay? But it's all just chemicals, it's all redox that's happening here, okay? So that's your batteries. You also have fuel cells, which a fuel cell is a little bit different because a fuel cell, you actually have to, it's more like an engine in the sense that you have to keep putting the fuel in, all right? Now, one fuel cell that's been, scientists have tried for a long time to make this really efficient and make it work because it's such a cool idea, is the hydrogen fuel cell, okay? And the reason that this is so cool, if you can use hydrogen as your fuel and burn it with oxygen, then you've got H2O only coming out of your tailpipe, right? Which, that's kind of a cool idea. It's related to, it's a redox reaction that's happening in here, but again, it's not, you can't really call it a battery because you have to keep putting in the hydrogen. It's more of, you can also kind of think of it as a combustion reaction that's happening there. But it really is redox because you've got, I mean, the H2 and the O2 both have a zero oxidation state to start out with. One of them gets oxidized, one of them gets reduced when it changes to water, okay? So then you just have oxygen and water, excess oxygen, assuming that we have excess of oxygen, and water coming out the exhaust, which is a pretty cool idea, right? So that's a hydrogen fuel cell. The other fuel cell that they talked about in the book that I thought was interesting was a, I'm forgetting all of these now. I think it's a methanol fuel cell, but I'm going to look that up just to make sure that I'm telling you right. Yeah, I'll pause the video while I'm looking it up. Okay. All right. So the hydrogen fuel cell we were talking about, whoops, what's going on? Oh yeah, I'm sure I already changed it over there. Yep, there we go. And I was right, it's a methanol fuel cell. I don't know why it just didn't sound right for some reason, but That's another one that they're really looking into right now. Methanol is a little more practical as a fuel than hydrogen is right now. They're just having trouble figuring out how to make the hydrogen work. Methanol is, so that could be one of the solutions. So there's a little, on page 874, there's a little article about direct methanol fuel cells. It would be good to read that as well. Basically, there's no practice problems on this section at all. It's really just reading it and kind of understanding, okay, here are the different types of batteries and here's how they work. Okay, and then the next section is corrosion and how to stop corrosion from happening. Okay, so this diagram is one of the diagrams in the book. Obviously, we know that iron rusts, right? I think we all know that. In other words, iron undergoes oxidation, which is actually where that oxidation term came from in the first place, was things combining with oxygen get oxidized, because oxygen is pretty selfish with electrons, and usually when it combines with something, it takes the electrons away from the other thing. Okay, so if something is losing electrons, it's getting oxidized. So combining with oxygen, oxidation. But this oxidation process, this rust process, can be sped up if you have water, if you add water, and also if you add some sort of salt to the mix, because then you're making a really good, essentially a voltaic cell at that point. You've got your cathode and your anode, and you've got if you've got the salt in there as well, then you have a nice salt bridge, right, so that it can keep the reaction going. And so you can see your two reactions that you've got going on there. Okay, and it's either making water as the byproduct or OH minus, I guess, is the byproduct there. But either way, the iron's getting oxidized, and that's the part that makes the iron oxide, which is the rust deposit. Okay, so basically this is just showing this oxidation will happen in air because there's oxygen in air, but it will happen a lot faster. You're essentially making a much more efficient voltaic cell if there's water and salt involved, which explains why, if you want to take care of your metal things, don't leave them in the wet. And, this is why you should probably wash your car off after you've been driving it around in the wintertime, because all the salt on the roads can spray up, get, on the underneath of your car, and then can start it rusting because you've got the salt and you've got the water. So that's corrosion. Now, something you can do to prevent corrosion is have something called a sacrificial anode. And what that is, it's something that has a higher tendency to be oxidized than the iron, right? So you put some zinc right next to iron. Well, the oxygen is going to go, or I guess what I should say is the zinc is going to give its electrons to the oxygen before the iron will. So you've got a piece of zinc right here. The zinc will get oxidized first. Okay, and so as long as you have some zinc there, it'll prevent oxidation of the iron, and so that's called your sacrificial anode there. Okay, and that's one way to keep the iron from rusting. Yeah, the zinc will oxidize, right? So that. Well, okay. Usually, what you do is you put the sacrificial anode somewhere in the vicinity of the iron. I mean, you can also, there are other strategies for rust prevention with iron, right? You can, stainless steel is mixed with chromium, and chromium has a tendency not to, well, does it have a tendency not to oxidize as much, or does it oxidize more readily? I'm going to have to look into that. I know that when you make that alloy, it prevents the iron from rusting. I'm not sure exactly why, but you can make an alloy as well. But they do this sometimes with ships. They'll put the sacrificial anode next to it. And that will keep the iron from rusting. Okay, so that's one way you can prevent corrosion. All right, and we're not doing this yet because that's electrolysis. We'll do that tomorrow. So that's it. We're done. Told you it would be fast. But just make sure that you look over those different types of batteries and and the corrosion and stuff like that. Because again, it's not going to be on the AP exam, but it will be on my test. All right, see you guys tomorrow.